This video has been brought to you by Limitless Learning TT, a holistic learning center. In this session, we will review number 6 of the May-June 2018 Paper 2 for Pure Math Unit 1. To see more material like this, you can go to our website, hover over the Outreach tab and click Free Material, or you can check out our YouTube channel. For more information about the services that we offer, you can visit our website, that's limitlesslearningtt.com, or email us at info@limitlesslearningtt.com, or give us a call at 868-610-1532. Okay, so let's get started. Number 6 gives us a piecewise function. Function f of x is defined by this piecewise function that says x to the power 4 minus 1 over x minus 1, then x is equal to 4x, and then f of x is equal to 2. This is when x is less than 1, when x is greater than 1, and when x is equal to 1. So this piecewise function, and the first part of A asks us to determine whether or not the limit of f at x is equal to 1 exists. Now, in order for a limit to exist, it must mean that when you come from the left-hand side and when you come from the right-hand side, it approaches 1, the limit exists on both sides, and that both are equal to each other. Right, so what we have to do is the limit that we're looking to go towards is 1 when x is equal to 1. So the limits when x approaches 1 negative means you're coming from the left-hand side of f of x has to exist, and that also has to be equal to the limit as x comes from the right-hand side of f of x. So if you're coming from the left-hand side towards 1, it means that x is less than 1. So we're actually looking at that first function. So the limit of x to 1 negative of f of x, right, is we're looking at the limit when f of x is going to be equal to x to the power of 4 minus 1 over x minus 1. Now, if we substitute x to be equal to 1 into this equation, we are going to end up with 0 over 0, which is undefined. Once we get down to that 0 over 0, which is undefined, we need to find a way so that it's not 0 over 0, right? And the way that we're going to do that is we're going to kind of do a little bit of algebra so that we don't have that denominator, which x minus 1, because when x is equal to 1, you're going to have your denominator going to 0, which is something that we cannot have, that's undefined. So we're going to find a way to get rid of the denominator, and we can do that by recalling the difference of two squares. So x to the power of 4 minus 1 is a difference of two squares, where 1 is the same thing as 1 squared. So that can be broken up into x squared minus 1 times x squared plus 1, right? Because x to the power of 4 is the same thing as x squared squared, right? Difference of two squares. And then this is also another difference of two squares. So this can be broken up into x minus 1 times x plus 1, and then what we got from before, which is x squared plus 1. So now I'm going to replace my numerator with this. So I have x minus 1, x plus 1, x squared plus 1 over x minus 1. And this is great because my denominator is going to cancel with this factor. And what I'm left with is just x plus 1 times x squared plus 1. And so now I can substitute in 1. And that's going to give me 1 plus 1 times 1 plus 1. Well, 1 squared plus 1. 1 plus 1 is 2. 1 squared is 1 plus 1 is 2. 2 times 2 gives me 4. Right? So if I am approaching the limit x from the left-hand side, my limit is going to be equal to 4. Now I need to check what happens when I am approaching my limits from the right-hand side, which is looking at 1 plus, and then that f of x that's going to correspond to that is when x is greater than 1. So I'm looking at 4x out of my piecewise function, and once I substitute x being equal to 1 into this function, I'm going to get 4 times 1, which is equal to 4. So since the limit exists for both of these, when I am going from the left or when I'm going from the right, and both of those limits are equal to each other, which is 4, it means that the limit of my function f at x is equal to 1 exists. Right? So that's part 1. Great. Part 2 asks to find out whether f is continuous at x is equal to 1. So I just want to put in here my limit exists and my limit is equal to 4. Okay, so we're going to keep that in mind for our next part, which is asking to find out whether it is continuous or not. Now, if a function is continuous at, in this case, x equals to 1, it means that 1, your limit must exist, and then the limit must also be equal to f of 1. Right? So what I'm saying is I need to have, in order for it to be continuous, my limit L has to exist. L must exist, which I know does exist because my limit exists from part before my limit is equal to 4. My limit must exist and my limit is equal to 4. And then also f of 1 has to be equal to my limit L. Right? If I'm looking to find f of 1, it's going to be looking at the function when x is equal to 1, which is 2, right? This part right here. When x is equal to 1, f of x is equal to 2, so therefore f of 1 is equal to 2. However, 2 is not equal to L, right? So f of 1 is not equal to my limit L because 2 is not equal to 4. So because they are not equal, it means that f is not continuous at x is equal to 1. So f is not continuous. Right, so that is 6, part E. Okay, moving right along to part B. We're given a parametric equation of a curve. We have x is equal to 2 times cos of theta, and then we have that y is equal to 3 minus sine of theta. And so they ask us to find d dx of g of x in terms of theta. Right, so d dx of g of x, which is the equation of the curve given by x is equal to 2 cos theta and y is equal to 3 minus sine theta. The way that we can find d dx, which is the same thing as like dy dx, it's going to be dy d theta multiplied by d theta dx, right? Because the d thetas will cancel out and just leave me with dy dx, which is what I'm trying to find out. And now I can find dx d theta and dy d theta using my parametric equations that are given, right? So from this, I know that why is this not behaving? Dx d theta will be equal to the differential of cos theta is minus sine. So this becomes minus 2 sine of theta. And then dy d theta will be, the differential of 3 is simply going to be 0. And the differential of minus sine is going to be minus cos of theta. So minus cos theta. Right, so now I have dx d theta, but I need to know what is d theta dx, which would just be the reciprocal, or negative 1 over 2 sine of theta. And I'm going to multiply those two together to give me dy dx. So dy dx is going to be equal to dy d theta, which is minus cos of theta, multiplied by d theta dx, which is negative 1 over 2 sine of theta. And so this can simplify to the negative signs cancel each other out, and so I end up with 1/2 cos of theta over sine of theta, and I know that cos of theta over sine of theta is the same thing as cotangent of theta, so cot theta. Right, so that's part 1. Part 2 says determine the equation of the normal to the curve at the point square root of 3 5 over 2. So what I'm going to do is just write again. I'm going to just write what the gradient function is. So just give me a second. Right, so we want to find the equation of the normal. Now, the first thing that we need to do in order to find the equation of a straight line, which is a normal, is have the gradient of the normal and a point that's on the line. We do have a point that's on the line. The point is square root of 3 5 over 2, so that's great. But we don't have the gradient of the normal. But we know that the gradient of the normal and the gradient of the tangent are perpendicular lines. So if we can find the gradient of the tangent, we know that the product of the gradient of perpendicular lines are -1. So then we can find the gradient of the normal. So how can we find the gradient of the tangent? That's easy. We have the function right here, right? This is our gradient, and this gradient represents the gradient of the tangent. So what I want to find out is my gradient when I'm at that point. So at that point, x is equal to square root of 3 and y is equal to 5 over 2. So what I can actually do is find out what theta is at that point and then substitute that into my gradient function. So I'm going to use either my x equation or my y equation. It doesn't matter. They're all going to give you the same answer. All right, so our function is that x is equal to 2 cos of theta, and so at this point x is equal to square root of 3. So square root of 3 is equal to 2 cos theta, which means cos of theta is equal to square root of 3 over 2. And then you should just remember that theta has to be equal to 30 degrees because these are one of the values of those functions that you're supposed to know, right? You're supposed to know what sine, cosine, and tangent is for 30 degrees, 45 degrees, and 60 degrees, and 90 degrees. Right? So theta must be equal to 30 degrees. So basically, I want to find dy dx, a half the cotangent of theta, which is 30 degrees, cotangent of 30 degrees. So cotangent of 30 degrees is actually the square root of 3. 1/2 times the square root of 3. Now, if you did not know that cotangent of 30 degrees was square root of 3, again, remember, you know that cotangent of theta is the same thing as cos of theta over sine of theta. So you could have found cos of 30 degrees over sine of 30 degrees. Cos of 30 degrees is the square root of 3 over 2 divided by sine of theta, which is 1/2. And so when you divide these two, you get square root of 3 over 2 multiplied by 2 over 1. The 2's cancel and you're left with square root of 3 over 1. So if you didn't actually know the value off the top of your head, you can also find it. Right, so now I know that my gradient dy dx, this is of the tangent line, is going to be square root of 3 over 2. And so that means that the gradient of the normal has to be equal to -2 over the square root of 3. Why does it have to be? Because when I multiply those two gradients together, I'm supposed to get -1. If I multiply square root of 3 over 2 by -2 over square root of 3, these cancel, and I'm left with -1. Right? So I now have my gradient of my normal A, and I also have a point on the line, square root of 352, and so now I can use point slope form in order to find the equation of my normal. So point slope form is y minus the y coordinate is equal to your gradient m times x minus the x coordinate. So y minus my y coordinate is 5 over 2 is equal to my gradient of my normal, which is -2 square root of 3 multiplied by x minus my x coordinate is square root of 3. And so now I'm going to expand that. Y minus 5 over 2 is going to be equal to -2 over the square root of 3 times x. -2 over the square root of 3 times -3. Negative square root of 3. The negative signs are going to cancel to give me something that's positive. The square root of 3's are going to disappear, and I'm just going to be left with +2. And so now I have to take the -5 over 2 on the left-hand side over to the right-hand side. So I get y is equal to -2 over the square root of 3 times x plus 2 plus 5 over 2. 5 over 2 is the same thing as 2.5. So +2 plus 2.5 gives me +4 and 1/2. So this is your final equation. Y is equal to -2 over the square root of 3 times x plus 4 and 1/2. Right, so that brings me to the end of part B. And so now part C. It says the slope of a tangent of the curve G at any point xy is equal to the product of the x coordinate and the reciprocal of the y coordinate at the point of tangency. Right, so the slope, remember slope is the same thing as gradient. So what they're saying is that dy dx is equal to x, the x coordinate, which is x, multiplied by the reciprocal of the y coordinate. Reciprocal of the y coordinate is 1 over y. So x times 1 over y is the same thing as x over y. Right, so that's just from the first line. Formulate an appropriate differential equation and find the equation of the curve family. Well, I just came up with the differential equation. It's dy dx is equal to x over y. That's from the first line. And so now I need to find the equation of the curve, right? Equation of the curve, which means I am just going to integrate both of these sides, because if I integrate dy dx, it's going to give me y, which is actually the curve. So I am going to integrate with respect to x, right? So only x matters. So the integral of dy dx with respect to x is equal to the integral of x over y with respect to x. This is simply going to go to y. On the right hand side, only x is the variable, so that means that 1 over y is treated like a constant, the integral of x with respect to x. And so this is going to give me 1 over y times, this now becomes x squared over 2, right, plus c, because it's an indefinite equation, indefinite integral, sorry. Great, so I now have that y is equal to x squared over 2y plus c, right? I can multiply 2y by both sides to give me 2y squared is equal to x squared plus c. I mean, multiplying your constant c by 2y squared, it's still going to be a constant, right? So plus c. And so now they're asking you to find. Okay, guys, sorry, I want to do this over. Sorry. Yeah, no, I want to do this over. I think that I made an error. Yeah, so, sticking with my dy dx is equal to x over y, I think instead I'm going to multiply both sides by y to get y dy dx is equal to x, right? It's like I'm isolating x's and y's, right? And what I want to do now is to integrate both sides with respect to x. Alright, so I'm now going to drop an integral sign here with respect to x, and then also on this side with respect to x. That means that this dx and this dx will cancel. So on the left hand side I will have the integral of y with respect to y is equal to the integral of x with respect to x. And so now the integral of y with respect to y should give me y squared over 2. And then the integral of x with respect to x will give me x squared over 2 plus c. I need to have a constant. I just need to have one constant. I don't need to add both constants to each side because there is just going to be a constant in there. Right? So this is where I'm down to. Yeah. So you can leave it like this, or you can rewrite it as y squared is equal to x squared plus c. Right? And then you can multiply everything by 2, or you can just leave it at this, right? So you can either say y squared is equal to x squared plus 2c, or you can just leave it like this, as in leave it as 1/2 y squared is equal to 1/2 x squared plus c. And so the next part says, hence or otherwise determine the equation of the curve given that it passes through the point 1, 3. So my point is 1, 3, and again, you're trying to determine what c is going to be equal to. So you just plug that into your equation, and so you get I'm going to stick with the y squared part. The y squared over 2 is equal to x squared over 2 plus c. Y cubed will be 3 squared over 2 is equal to 1 squared over 2 plus c. So 9 over 2 is equal to 1/2 plus c. 9 over 2 minus 1/2 is equal to c. 9 over 2 minus 1/2 will give me 8 over 2, which is equal to 4, which is equal to c. So basically, your full equation will be 1/2 y squared is equal to 1/2 x squared plus c, which is 4. And then now, if you want to just multiply, get rid of the 2, you can say y squared is equal to x squared plus 8. Right? And so, my thing is, though, that you can always double check to make sure that your stuff is in fact right. Because what you're supposed to say, remember, if we got our equation to be y squared is equal to x squared plus 8, right? It means that when we differentiate that, we're supposed to get back dy dx is equal to x over y, right? So we just want to do a fact check to make sure it's going to work out. So we're going to differentiate with respect to x. So y squared with respect to x, differentiating will give me 2y dy dx. This will give me 2x, and my constant 8 becomes plus 0. So just 2x. And then divide both sides by 2y to give me dy dx is equal to 2x over 2y, which I end up with dy dx is equal to x over y. Right? So you can always double check to make sure that you do, in fact, have the right equation. So this would have been my final equation of the curve when it passes through the point 1, 3, right? And this one to be the equation of the curve family. So that brings us to the end of number 6 on the May-June 2018 paper 2 for Pure Math Unit 1. Again, this session has been brought to you by Limitless Learning TT, which is a holistic learning center. For more material like this, you can visit our website. Again, hover over the outreach tab and click free material. You can also follow us on our YouTube channel. And if you're looking for more services that we offer, including our exam crash course, so for those details you can check out our website at limitlesslearningtt.com. You can send us an email, that's info@limitlesslearningtt.com, and you can also give us a call at 868-610-1532. For those of y'all who do not reside in Trinidad and are checking these videos, if y'all are interested in doing like an online exam crash course session, be sure to send us an email and let us know. Thanks, guys.